It really looks similar to what we saw a moment ago. Okay, see if you can follow the same train of thoughts, okay, to analyze this question. So let's say that depending on how the two possible solutions for x compare to 0, then we will have clearly option A or option B, or perhaps option D. But it'd be hard to expect option C. This can never happen here. Why? Because we'll clearly obtain two different values as possible solutions for x. But what are these possible values? Well, the idea here is we don't know. At the very beginning, we don't know what is the sign of this expression. Is 2x plus 6 positive or negative? Well, it depends on the value of x, but x is unknown. So we need to assume, in turns, each of the two possible scenarios. So first scenario, if 2x plus 6 were greater than 0. In such case, we can assume, since we are talking about a positive expression, the absolute value of this positive expression will simply be the same expression, because it's positive. And we know that the absolute value has to yield a positive result, or 0 perhaps, but never negative. So the absolute value of 2x plus 6, assuming 2x plus 6 is positive, must be the same, 2x plus 6. And since this was equated to 4, then from this we can find a possible value for x. 2x must be 4 take away 6, or negative 2, from which x equals negative 2 divided by 2, or negative 1. So we have a first possible value. Now, keep track of what would be the answer if we assume that x equals negative 1. Which is greater, negative 1 or 0? Clearly, 0. So this would yield option B for our response. Now, let's try to do the same with the second scenario. So we have this. If 2x plus 6, because we don't know the sign of this expression. Let's clarify here a little bit. When I say the sign of this expression, I refer to the sign of its numerical value. Because you say, why do you say the sign of 2x plus 6? I don't see any sign before 2x plus 6. Here I see a sign. Okay, it has negative sign. No, we don't mean that. A number could have a negative sign, or an expression could have a negative sign in front of it, but that doesn't determine the sign of its value. For example, this could be positive. How come? How come this could be positive? If this is 5, that is, this is a positive number. It's positive because x has to be negative. Because if x is negative 5, minus negative 5 equals 5, a positive number. So don't get carried away by the fact that you observe there is a negative sign in front of the expression you want to analyze. If there is a negative sign, that doesn't tell you what is the sign of the numerical value of that expression. It simply doesn't. So when I talk about the sign of 2x plus 6, I'm not talking about any physical sign that you can see before the expression. I'm talking about the sign of its value. So 2x plus 6, if x is a number, a real number, 2x plus 6 must be a real number as well. That real number is positive or negative. That's what we don't know. So if 2x plus 6 were a negative number, then I can infer that the absolute value of this expression will simply be the inverse additive according to the definition of the absolute value. Whenever you have something negative, the absolute value of a negative number is always its positive alter ego. Okay? So to make the positive, or let's say the version with inverted or change sign of 2x plus 6, all I have to do is multiply this expression by negative 1. Because if 2x plus 6 is negative, by multiplying it by negative 1, I'm turning it positive. So this will be the absolute value of 2x plus 6. And now I'm equating this to 4. So from this I can follow, plainly, in order to find another value for x, right? So we have negative 2x plus 6 equals 4. This is the same as saying 2x plus 6 equals negative 4. And from this we have that 2x must be the same as negative 4 take away 6, or negative 10. Therefore x equals negative 10 over 2, or negative 5. Now we have our second possible solution. So in this equation, x is either negative 1 or negative 5. Another way to view this analysis is like this. You might wonder, okay, if the absolute value of a certain expression equals 4, then this is easy. Which numbers have an absolute value of 4? Only 2 in the universe, 4 and negative 4. This means that you can analyze this equation in the following manner. You can say, okay, my first possibility is that 2x plus 6 is actually the number 4, because the absolute value of 4 equals 4. Or you can say that another possibility is that 2x plus 6 actually equals negative 4, because the absolute value of negative 4 will also be 4. So, by analyzing the two scenarios directly in this manner, you can find x faster. I'm doing this way here in order to show you and to justify, okay, with the appropriate rationale, what's going on, why we reason as we reason on the left side. But the idea is, what we really do is apply the double definition of the absolute value function whenever we don't know the sign of the expression inside the absolute value operator. Okay, so that's why noticing that x being negative 1 is less than 0, and noticing that x being negative 5 is also less than 0, clearly here we have just a single possible response. There's no uncertainty about our response. The greater quantity will be b in both cases. In other words, always. So that's a correct choice.